So here's day three's high points that I want you to know about. Remember, on day 3, you're reading about the seasons, phases of the moon, and eclipses. I just wanted to show this picture of the celestial sphere. We talked about it yesterday. Remember that the celestial sphere is a model that we use to help us visualize the sky. It also helps us understand certain things that we see, such as the motion of stars during the course of the night. We already talked about how there's a celestial equator in the sky. It's an imaginary line that is extended from the equator of the Earth. This line right here isn't something that I showed you earlier, but it's important. This line is called the ecliptic. This is actually the path that the sun follows during the course of the year. Remember that the sun appears to be in different locations in the sky as during the year, and this is caused by the Earth's revolution around the sun. The ecliptic is also known as the path that the Earth takes around the sun. It can be defined either way. Just one quick thing about seasons. There's some other videos that I have that explain seasons in more detail. But you might know that, of course, there are certain times of the year when we say it's the first day of summer, the first day of winter, etc. If we look at the celestial sphere, notice that the ecliptic and the celestial equator intersect at 2 points, right here and over here on the other side of the celestial sphere. When we're at these 2 points, these are actually called the equinoxes. Those are the times when the amount of daylight is equal. They're also defined as the first day of fall and spring. So this is where the sun is located in the sky on the first days of fall and spring. Up here at this high point is the first day of summer for the northern hemisphere, and down here is the first day of winter. So I just wanted to show you how we determine these first days of the seasons. It actually has everything to do with where the sun would appear in the sky, and it's also related to the orientation of the sun with respect to the ecliptic and the celestial equator. So, phases of the moon. When we first learn about the phases of the moon, or when we're first thinking about it, our instinct is that the phases of the moon might be caused by the shadow of the Earth on the moon. That is, the sun is shining towards us, and if we are between the moon and the sun, maybe we cause a shadow on the moon, and that's why it goes through its phases. The problem with this idea is it would never really explain to us how we could see a full moon, and it also wouldn't explain how we see moon at different times of the day. We might think of the moon as a nighttime object, but think about it. You've actually seen the moon out during the day, sometimes in the morning, sometimes in the afternoon, but it is visible during the day when it's in certain phases. So think about what causes the phases of the moon. We have to think about some things that we know. We know that the moon does not produce its own light. It's only reflecting light that comes from the sun and bounces off of it. So this means that because the moon is a sphere, only half of it can be illuminated from the sun at a certain time, well, at all times. The side of the moon facing the sun is the side that's lit up. But we might not actually see all that lit half of the moon. We only see a part of it, and that's going to determine what phase it's in. If we see the entire lit half of the moon, we know it's in the full moon phase. If we don't see any of that lit side, then it's in new moon. If we only see half of it illuminated and half of it dark, it's either in the first quarter or third quarter phase. So the reason that we only see different portions of it is because the moon is revolving around the Earth while the Earth is revolving as well. So this picture shows us how we could sort of model the phases of the moon. The person is holding a ball and holding it up towards the sun. Notice the side towards the sun is the side that's lit up, and the side that's opposite that is the dark side. So as she moves her arm around, she's going to see different amounts of this lit side. Right now she can't really see any of it. Well, in this picture maybe just a sliver. But if she put it back here, she would be able to see the entire lit side, and that would correspond to a new moon, full moon. So notice at the different locations of this ball around her in the orbit that it would follow, that you see the different phases. Just to kind of keep in mind, if we're viewing our solar system from the top, virtually everything is moving in a counterclockwise direction. And notice this is true here as we're showing the phases of the moon. Notice that when the moon is right here, it would be in the new moon phase. Back here, it would be in the full moon. In between these 2 points are first quarter and third quarter, named because they're either 1/4 of the way or 3/4 of the way through the entire phase. And then as it's gaining lit up part, we call it a waxing phase. This is a crescent, this is a gibbous. And as it's starting to decrease the amount of lit part of the moon that we see, we call it waning. Again, gibbous and crescent. Notice also in this picture how it talks about when the moon rises and sets, and this helps us understand how the moon is seen during different times of the day. Here's another picture showing the different phases of the moon. Over here is where the sun would be. The Earth is right here. Notice that we're rotating here on the axis as the moon is orbiting around us. So as we rotate, even though the phase of the moon remains stationary, our rotation allows the moon to appear to rise and set during the course of the day. The moon actually has 2 different periods. The first period is a sidereal period, and that's the amount of time it takes the moon to go completely around the Earth once if we compare it to the background of stars. That is, if we say, okay, the moon is in this constellation, and if we wait until the moon appears at the exact same place in that same constellation, that would take 27.3 days. The synodic period is the amount of time it takes the moon to complete all of its phases. That's actually a little bit different. It's 29.5 days. We might have had it in our mind that the moon's phase is about 30 days, which is approximately correct. It takes about 1 month for the moon to go through all its phases. The reason that these 2 periods are not equal is simply because the Earth moves as the moon is revolving around it. So in this picture here, we see that the Earth, the moon, and the sun are all lined up, and this is a new moon phase. If we allow the moon to begin revolving around the Earth and we wait for it to be in the same location with regards to the stars, notice over here now the Earth is here, and this line right here represents when the moon would be in its same location relative to the stars. Notice that this line right here is parallel to this line. This would be when the moon has completed its sidereal period. But notice it's not lined up with the moon, with the Earth and the sun, so it's not time for the new moon phase. It has to move a couple days until it lines up for new moon again. So it's this revolution that causes these 2 periods to be unequal. The moon exhibits what we call synchronous rotation, which means that it takes the same amount of time for the moon to revolve around the Earth as it does to rotate on its axis. That means that the same side of the moon is always facing the Earth. This has to do with the gravitational interaction between the Earth and the moon keeps the same side facing the Earth. That's where the idea comes from, the dark side of the moon, but it's not actually the dark side of the moon, as you can tell here. We should actually call the side of the moon that doesn't ever face the Earth, we should call it the far side. And we'd never get to see it unless we took a spacecraft over to see that. This is a picture sort of showing the synchronous rotation. This is not a synchronous rotation here, and this is. She's going around the central object, which would represent the Earth once. But notice she also goes through one complete turn, starts facing this way, and by the time she's done, she's facing this way again. I'm going to stop here and talk about eclipses in a separate video.